Okay, day 11. I made it on time. Here's our first set of data. Oh, we need that. Let's go throw that in our input. Okay. 100 octopuses arranged in a 10 by 10 grid. Each octopus slowly gains energy over time, flashes brightly for a moment when its energy is full. Though the lights are off, maybe you can navigate through the cave without disturbing octopuses. You can predict when the flashes will happen. Energy level, for example. Energy level of each octopus is 0 to 9. Here the top left is 5. Yep, okay. All the energy levels and flashes of light in steps. During a single step, the following occurs. Everybody goes up 1. Any octopus with greater than 9 flashes. This increases the energy level of all the adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increased beyond 9. Finally, any octopus that flashed during this step has an energy level set to 0, as it has used all of its energy to flash. Adjacent flashes cause an octopus to flash on a step, even if it begins that step with very little energy. Consider the middle octopus here. After step 1. So we also need to know whether the thing is flashed. It's not just enough to know what its level is. Yeah, we'll worry about that in a minute. After step 10, there have been a total of 204 flashes fast forwarding after every 10 steps. So we need to know total number of flashes after 100 steps. All right, so what is our data structure going to be here? All right, we want to parse the line. And so our grid of octopuses. Right, let's do this. Let's say record octopus. Octopus. All right, we're going to have int energy pool flashed. Sounds good. What are you upset about? Naming rule violation. Whatever. Okay. So what we want out of this is basically we're going to do a double array of octopuses, right? So line. So this is going to be an array of octopuses. Okay. For each C in line, we're going to do energy be and 64, no, int 32 is fine. Int parse, yeah, so int parse that. Alright, result is a new list of octopus. Result to array. Okay, so then we add a new octopus, which has energy and force. Okay. So when this comes back, we should have an octopus double array. We do. The next thing we need to do is we need to say void step. Actually, let's do long step, right? Because we want to count how many flashes we see. Let's do max x is data length. Alright, and then max y is data 0 length. Okay. X is 0, x is x is 0, x is less than max x. Alright. Y is 0, y is less than max y, plus y. Okay, if not, let's see, octopus data, so if you have not already flashed, alright, then what we want, why are you upset? Data may be null here? No, it won't be. Okay. So if you haven't flashed, then your energy goes up. Init only property or index or octopus energy can only be assigned. Oh, so right, this needs to be a class record? Or record class. You know what? Whatever. Int energy pool flashed. We'll do it this way. Energy is energy. Flashed is false. Alright, you guys need to be public. Okay. It's fine. Not all code paths return a value. 1, 2. Yeah, that's just whatever. Let's see. So your energy goes up. Let's do this. So we can stop doing this. We're going to extract this out. Alright, and what I'm going to do is I'm going to say results plus equals process octopus x, y. Let's do this. We'll say long process octopus. Alright. We're going to do this. X is greater than or equal to max x, or y is less than 0, or y is greater than or equal to max y. Why do I have max x over there? Max y over there? We'll just go ahead and return 0. Alright, so we'll start here. Return results. Think, maybe. If the energy is greater than 9, then so you're going to stay there as 0. If your energy is more than 9, then we're going to return 1. And we need to process wait a minute. So what we want is, let me make sure that I understood this correctly. Every octopus goes up by 1. Then any octopus with energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1. Right. So this loop is make sure everybody goes up at least 1. New energy is double plus octopus energy. Actually, maybe we shouldn't do that. This should be up here. Alright, this is the one that's basically going to say, hey, everybody goes up 1. Alright, so we're going to say data x, y, energy, plus plus. Okay. If you haven't flashed, and your energy is greater than 9, Actually, no, we do want that down here because every time somebody flashes, we want to go process everybody else. I was wrong. This is... New energy is double plus octopus energy. So if you're here, it's because you need to go up 1. So if you haven't flashed... This doesn't need to return a count, I don't think. All I want to do is I want to say that you flash. Alright? All I want to do is say that you flash. So octopus flashed is true. And then we want to say... process octopus x minus 1, y minus 1. So x minus 1, y, x minus 1, y plus 1. X, y minus 1, x, y plus 1, because we don't want to reprocess ourselves. So these are both plus, and that's minus, and that's plus. Okay, so when that's done, that'll basically flip through the board. And then we need to count the number of things that flashed, right? So we'll do this loop again. Right, and we'll say if data x, y flashed, then we need to say data x, y flashed is false. We add 1 to our results, and data x, y becomes, energy becomes 0, right? Final octopus flashing, flash during this step has its energy level set to 0. Use all of its energy to flash. We only need to increment our own energy if we haven't flashed. Because once we've flashed, then that's fine. We don't want to just keep rolling energy forever, right? So that means that so if you haven't flashed and your energy is now greater than 9, then you have flashed and everybody else has to go. But if you've flashed, then we don't have to increase your value, and we don't have to keep going. Because you only flash once. Okay, so that should get us there for step. So what we need to do is we need to do 100 steps. So let's say print grid, right? And then for index is 0, index is less than 100. Double plus index. We're going to step. We need a result plus equals step. And then we're going to print the grid. Because this is going to be the easiest way for us to see that we've done this quickly. So let's print the grid. Which... this. The only time we should ever see 0 is when somebody flashed. Okay, so we'll do our loop. All right. Console write data x, y, energy. Console write line. That should be it for the grid. Now let's see what happens here. Oh, right. Print grid. Zero and then 90x plus 1 because we want to print step. Step. Let's do just 2 of these to start, 3 of these to start. So that should be step 0. So let's take a look at this. All right, and then we got 6, 5, 9, 4, blah 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 blah. So we have a bunch of 9s, no 0s yet. 880, 747, 6555, 508, 908, 7054, 608, 600. There's the zeros, the zeros, the zeros, the zeros. This all looks pretty good. Okay, so let's go ahead and not print any more grids. Let's just get our value here. How many flashes did we get? We didn't get any flashes because we got to return the result. What is our result? 1656. 1656. All right, let's go get our real data. That's our real data. Oh, okay. Why not? 1637. Looks good. All right, seems like flashes aren't bright enough to navigate. However, you have a better option. Flashes seem to be synchronizing. In the example above, first time all the octopuses flash simultaneously is step 195. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all the octopuses flash? Okay, that should be pretty easy to get, right? Our first full flash, we'll do this as a nullable long, right? And then we'll do a step, and then flash count. All right. Oh, actually, we already know the flash count. If the first full flash is null, and the result is equal to max x times max y, then the first full flash is idx. Let's see, step, right? So we'll do int step. So you need to step with the index. So let me go back to my old data. This should just return the first full flash. First full flash. Why are you upset? Oh yeah. First full flash dot value. It's fine. Okay. So if we run this, what do you say? Nullable object must have a value. Well, isn't that interesting? $195. Oh, we have to keep going. I see. So what we need to do is we need to say if first full flash is null. I want to say while first full flash is null, right? So our index is 100. We're just going to do step index plus plus. That should be fine. We get 195. We got 194. Probably because we started counting with 0. So let's just do a plus 1. Okay, let's put our real data back. Let's see what step we get on. 242. It's good. Okay. How did we do then? Leaderboard action. 969 and 1000. Not bad, not bad. Private board, I'm the only one working. Work. 3rd place again. So I actually hopped up from 5th to 4th in the final tally from yesterday. Probably will get knocked back down into 4th. We'll see. But that actually wasn't too bad. Cool. All right. Day 11 in the bag. I'll see you all tomorrow for day 12.